Hey everybody, welcome. Anselmo Martinez. I am a senior solutions architect here in AWS in the Southeast region, and I'd like to discuss with you some network hybrid architectures and gateway load balancer that was recently launched. So without further ado, let me share here my screen. Sorry, my slides.
No.
All right, so AWS VPN, right?
Let me
So
just,
I'm gonna
let me make sure, I want to make sure we're seeing the presentations here. One,
that one.
um, let me check. Maybe people, there we go. Now it says AWS VPN.
Okay, sorry, I think I clicked the wrong button here.
That's
All
fine,
right,
no problem.
AWS VPN. Yeah, so this is how a lot of people have their network architectures with VPN tunnels from on-premises to AWS, right? So before we had a VPC with a VGW, right, the virtual private gateway, and then we had on-premises on the right. So what we used to do is to have our customer gateway, could be a router, could be a firewall, and then we will build a primary tunnel, secondary tunnel over the internet, and we'll have the IPsec tunnel over there, right? So now we added some additional encryption, integrity, and exchange algorithms, and I have scan QR code here for you guys. And now we added the tunnel initiator mode. Not only on-premises could initiate traffic, but now you can initiate traffic coming from your cloud VPC, right? Um, we added a transit gateway, which you could terminate tunnels at as well, and you can do IP version 4, IP version 6. So the tunnel will support both protocols. The outside address must still be IP version 4, of course. And there's another QR code for you. All right, so transit gateway, right? So before you had your transit gateway, you had your VPCs, and you had attachments to all of these VPCs. You attach the transit gateway directly to the VPC, not to the VGW, by the way, up to 5,000. And then you have on-premises site-to-site VPN to the transit gateway. You have your VPC, maybe that's a transit VPC, and you do equal cost multipath to take advantage of the bandwidth on both tunnels, because each one of them is 1.25. You could also have direct connect gateway going back to on-premises, and maybe you have a colo in between, and you have a transit virtual interface. So you will have, there are different types of virtual interfaces, private and public. And when we came up with the transit gateway, we came up with a transit virtual interface that you have to have in order to communicate with the transit gateway. So again, before transit gateway, VPCs in one single region. And if I have the same architecture in the other region, then I will just peer these to transit gateways. And again, this is going to be the static routing. If I want to go from transit gateway A to transit gateway B, all I have to do is say, hey, all those subnets over there, I'm going to reach them through this peering right here. This is a new attachment type, and this is encrypted through the AWS backbone. No peering within the same region at the moment. So if you have multiple transit gateways, this is what you will do. We recommend a full mesh and use unique autonomous system numbers on each one of those transit gateways. We started with these regions right here before, but now we have more regions, right? We have new attachment level metrics using CloudWatch, and now we have more regions supported, right? So the more you grow, the more VPCs you're going to have. And if you start doing VPC peering, which is what we had before, um, it can grow exponentially, right? So it could become a nightmare. Maybe 1, 2, 3 VPCs is fine, but if you have dozens and hundreds of VPCs, then it is recommended to start using the transit gateway. And then if you have multiple transit gateways, just go ahead and peer them, right? More on transit gateway, you have your, let's say you have an outside VPC and an inside VPC and a security VPC with instances on the outside and the inside one. And then these two instances want to talk to each other because there's an application talking to each other right there. And then on the security VPC, you have a couple of appliances. Let's say you have firewalls right there, for example. So again, ENI attachments, when you attach a VPC to a transit gateway, what we do is we put an ENI on each availability zone. Okay, so just keep that in mind, and we will do the same thing on the security VPC, like that. So traffic comes from the instance A, it goes to a TGW, and then all the way to the appliance via the TGW attachment. On the way back, it goes back to the transit gateway, and then to instance B, back from instance B, and then to the other appliance, right? So we have an issue there. So traffic could end up on another appliance. Security appliances generally need flow symmetry to their job. So at this point, the firewall on the bottom will say, well, I haven't seen this traffic, so I'm just going to go ahead and drop this traffic right here. So now what we have is the TGW appliance mode, okay? So you will have the same traffic coming from the instance on the top, going to the firewall on the same availability zone, by the way, and then it is coming, it is going to its destination, and then it goes back, and then because of the appliance mode, it is going to honor the same availability zone that the traffic came from, right? So this is very important. And then to the appliance, and then back to instance A. Okay, so that's something that you can do with the transit gateway. Flow symmetry is restored, right? And the return traffic is allowed through the appliances. Transit gateway connect, SD-WAN. So this is something new as well. If you have an SD-WAN overlay network, you could take advantage of this new functionality, right? Where you have an SD-WAN hub VPC, and that's in that hub VPC is where you will basically terminate your SD-WAN connectivity. You have your overlay there. You have branch 1, 2, 3, 4, 5. As many branches that you have there. You put your SD-WAN appliances in the cloud, and then those appliances will have a BGP relationship over GRE with the transit gateway. Okay, so that gives you way more flexibility in that sense that you could connect your SD-WAN overlay, and then the transit gateway will have connectivity, like we said, right back to the corporate SD-WAN. I'm sorry, corporate. Yep, and offices and whatnot, VPN or direct connect gateway, and then you have your connectivity to the VPCs, right? So just check this out if you are interested. All right, so now we're going to talk about the gateway load balancer, right? This is something Something big we released just last December or so. So before, let's just put a scenario here. We had our instances in the VPC, and then we had a couple of firewalls, right? So we have to have an active firewall and a passive firewall there, and an internet gateway if I want to talk out to the internet. So my instance will have a route table, basically saying, well, 10.100/16, that's my local VPC network. And if I want to go out to the internet, I'm going to send everything to my active firewall. And then my active firewall is going to say, well, I have my local subnet as well. And if I want to go out to the internet, I'm just going to send everything to the internet gateway. Okay, so at that point, the passive firewall is just that, right? A passive firewall. If you had a transit VPC, you have your transit, your hub, and then you have a bunch of spokes, right? Internet gateway, same thing. My spoke VPCs will have a VGW, virtual private gateway, that you could use to terminate VPN connections to both firewalls in this case for redundancy purposes. And then my spoke VPCs will send all the traffic to my VGW whenever they want to go out to the internet. In this case, the 10.2 is a local subnet. And so the VPN tunnels, that's what the VGW is what it will do. If I receive a destination with 000, I'm going to send everything to my firewall, right? With Transit Gateway, I have my VPC-A, I have my VPC-B, right? 10.100/16, 10.200/16. I have a couple of availability zones on each VPC, in this case 2. And so I have my transit gateway, right? So my transit gateway is gonna the VPCs are gonna be attached to the transit gateway, and then the transit gateway is going to just have an ENI elastic network interface on each availability zone. Okay. So on the other side, I have my inspection VPC, for example, where I have a couple of instances there. I'm sorry, yeah, firewalls. In this case, I have 3 firewalls there, okay, doing SNAT, source netting. So I have my equal cost multipath configured here. So I take advantage of the bandwidth, right? So just following the traffic flow here, if my instance on VPC-A wants to go out to the internet, then it will send all the traffic to the transit gateway. And then the same thing goes for the other instance, right? 000, I'm gonna go to the TGW. And then the TGW is gonna have route tables as well, route domains, right? In this case, this route table is associated with the 2 VPCs. And as soon as it sees the traffic coming and the destination is 000, I'm going to send everything to the outbound VPC VPN, right? And I have another route table in this case for the return traffic. So for the return traffic, if I want to send, if I want to go back to 10.1 or 10.2, I have a couple of attachments, and this is how I will get there, right? So you're controlling the traffic, manipulating your traffic using those route tables. All right. And obviously the inspection VPC also has a route table. Anything going back to the VPCs, go back to the transit gateway. Anything going out, go out via the internet, and then I have a local network right there. The famous ELB sandwich. So let's just go through this. So I have my internet gateway, and let's say I have a load balancer, right? This load balancer is basically sending everything out to the internet via the IGW, and then it has a local subnet /16 in this case. Then I have a couple of firewalls behind, and then another load balancer, and then the instances, right? So this is what we call the famous ELB sandwich. Those instances have obviously the local route table configured, and this is how the traffic flows will look like. Okay, so this was before the gateway load balancer. So after, we have a source and destination, and then we have an appliance fleet of firewalls, for example. So we have a gateway load balancer endpoints. This is a new type of VPC endpoint right here that will basically broker the traffic flows at this point. So my source will send everything to my gateway load balancer endpoint, right? Which is basically an extension of the gateway load balancer. And then the gateway load balancer is a new type of load balancer that includes a layer 3 gateway and layer 4 load balancer capabilities. So basically, we're all used to the classic load balancer, application load balancer, network load balancer. Well, now we have the gateway load balancer, right? Which is, okay, so right here. So traffic will flow, will go in that direction, right? And this is powered by the AWS Hyperplane. We're basically combining layer 3 and layer 4 capabilities, and then the gateway load balancer is going to front end those connections. It's going to front end those firewalls, right? And load balance accordingly. Using a gateway load balancer, basically, you can provide horizontal scale to your applications. You can perform upgrades on your firewalls and take them off the balancing mode and then put them back on whenever they are ready. Provides fault tolerance, is transparent to the network traffic. And by the way, in order to do this, you need the firewalls to support, or your appliances to support the GNIV protocol. This is for the encapsulation of the traffic between the gateway load balancer and the firewalls. So that's a requirement. You can separate security and user admin domains. So in this case, let's say you have a consumer VPC and a provider VPC. Well, you can call this firewall as a service, right? Deployment, you create a gateway load balancer in the appliance fleet using steps similar to the network load balancer, like I was saying before. Basically, you go to your EC2 dashboard and load balancers, and it's going to be right there. I'm going to send all my traffic to the gateway load balancer or load balancer endpoint, and that's how it works, right? So let's go through some traffic flows here. I have my application instances living in this availability zone, and then I have my gateway load balancer endpoint. I have another VPC with my appliance instances, and that's where I have my gateway load balancer right there, right? I have my internet gateway with a local destination with 10.100/16, and he's going to send everything to the gateway load balancer endpoint as the traffic comes in. The endpoint is just basically saying internet go to the internet gateway. Then 1 is my local subnet. My gateway load balancer has a local destination with the route table, subnet route table. And my application instances have a 000 pointing to the endpoint here, okay? So let's say the traffic is gonna come in through the internet gateway, and then it's gonna go to my endpoint. The endpoint is gonna take that and send it to the load balancer because it is an extension of it. And then here's where the Geneva protocols comes into the equation because I'm gonna send everything to the appliance instance. Traffic comes back, and then it's gonna go all the way to the instance. Return traffic is gonna basically be the same, right? Everything has to flow back and forth through the gateway load balancer all the way to the appliance instance and then out to the internet. Okay. We have a couple more slides here, not so many. So another example, appliance or security VPC, same scenario as before. I have my firewall fleet, and these firewalls are load balanced by the gateway load balancer. VPC 1, instance 1, internet gateway, and my endpoint. All right. So all that is encapsulation A. Yep, by Geneva. And then I have another VPC, VPC 2 in this case, same case, right? Encapsulation B. And then VPC 3, encapsulation C, and so on, right? So that's why you need the this Geneva encapsulation. Centralized security inspection with TGW. So I have a couple of VPCs again. Now I'm using a NAT gateway with an internet gateway, my transit gateway in the middle, and then my appliance or security VPC. Same thing here, nothing changes other than the NAT gateway. Everything is going out via the NAT gateway, north-south in this case, right? Traffic to or from the internet. So I could have another fleet of appliances for east to west traffic inspection behind another gateway load balancer. Okay, so this is another architecture that you could have. Yep, considerations, you could perform north, south, and east-west inspection using the same fleet. NAT could reside inside or outside of appliance fleet VPC. All right, so key takeaways. I know we're out of time here. Reduce complexity and deploy faster with the gateway load balancer. Elastically scale and reduce costs. Improve appliance availability. And supported by leading appliance vendors. Okay, so with that, I want to thank you for your time. Here's my email in case you have any questions. Feel free to send me an email, and we could discuss more about it. So thank you very much.